Welcome to the forensic analysis of the most expensive DevOps failure in financial history. 45 minutes, $440 million in losses. That is the calculated cost of the Knight Capital collapse, $10 million evaporating every 60 seconds. On August 1, 2012, Knight Capital, the largest market maker in U.S. retail equities, didn't just experience downtime. They experienced a total solvent collapse. But here is the critical insight for enterprise architects. The root cause wasn't a cyber attack. It wasn't an external breach. It was an internal zombie algorithm that had been dormant in their infrastructure for 8 years. And when operations tried to mitigate the risk, they made a strategic error that guaranteed liquidation. This is the forensic analysis of the most expensive DevOps failure in financial history. To understand the magnitude of this failure, you have to understand the business model. Knight's system, SMARS, was an algorithmic trading engine designed for speed. Its function was to fragment massive institutional orders into optimized child orders to secure liquidity. In high-frequency trading, latency is a direct liability. Every millisecond of delay impacts the profit and loss. Consequently, the architecture became aggressive. Deprecated code wasn't always refactored. It was often just disconnected to save engineering cycles. This created a latent risk within the codebase. Buried in the routing logic was a function called PowerPeg. It was developed in 2003. It hadn't been utilized since 2005, but it remained in the production environment, a dormant variable waiting for an input that should never happen. Let's examine the system topology. The engineering team was preparing for the NYSE's new retail liquidity program. To activate this new logic, they needed to repurpose an existing feature flag. They remapped a boolean flag that previously controlled the 2003 PowerPeg function to now control the 2012 retail code. The deployment plan was standard. Update the software on all 8 nodes in the cluster. Activate the flag. The new system runs. The legacy code remains inert. It was a routine update, but in distributed computing, unmanaged legacy code is a critical vulnerability. The deployment window opens. A technician manually pushes the new software build to the server cluster. Node 1, updated. Node 2, updated. They proceed through the list. However, due to a manual oversight, Node 8 was not updated. This failure to update left Node 8 with critical gaps. The new binaries were never copied. The server remained stuck in the past, running dangerously old code. Node 8 was essentially running a legacy snapshot. When the market opened at 9:30 a.m., the central controller sent the command, enable flag true. On 7 servers, true meant execute retail program. But on Node 8, true triggered the 2003 PowerPeg logic. Because the safety constraints had been removed years prior, the algorithm entered an infinite execution loop. 9:30 a.m., the opening bell. A deviation from the norm is immediately detected in the server cluster. Node 8 immediately begins accumulating positions, buying high and selling low, cycling thousands of times per second. The volume of trades overwhelms the system. The market is flooded with irrational volume. The financial losses mount rapidly, catching the attention of the operations team. Knight's operations team detects the massive capital hemorrhage. They are losing millions per minute. The team struggles to pinpoint the exact source of the problem. They identify the anomaly but lack the granularity to isolate the specific rogue node. Facing a crisis, they make the decision to roll back the deployment. They revert the system to the previous stable build. This rollback triggers an unintended and devastating chain of events. This was the point of no return. By rolling back the 7 updated servers to the old version, they reintroduced the code that interpreted the flag as the PowerPeg instruction. The faulty logic is now amplified across the entire infrastructure. Now, instead of one node running the irrational logic, all 8 nodes were executing it. They had inadvertently scaled the failure across the entire cluster. By the time the team physically disconnected the system from the exchange, 45 minutes had elapsed. The immediate consequence of the disconnect was staggering: a $440 million loss. This exceeded the company's entire profit reserves. The financial damage was catastrophic and unprecedented. The post-mortem reveals 3 systemic deficiencies valuable for any senior engineer. These 3 lessons are critical for avoiding future failures. The first major flaw was a lack of software hygiene. Unmanaged technical debt, code that is not in production, is a liability. If it is not refactored or removed, it is a latent threat. Next, the issue of inconsistent deployment. Manual deployment risks, especially in high-stakes environments. Relying on manual file transfers creates configuration drift. Humans cannot ensure state consistency across a distributed cluster. Finally, a failure in monitoring capabilities. The observability gap, the system was optimized for throughput, not semantic monitoring. They focused on if messages were sent, not if the messages made sense. The most crucial missing piece was a safety net. They knew the messages were sending, but they lacked the circuit breakers to stop irrational trading behavior automatically. These 3 lessons are paramount for all senior engineers operating high-stakes systems. Knight Capital was acquired shortly after by Getco LLC. The independent entity ceased to exist. This case study establishes a maxim for modern software architecture, the Knight Capital Law. The complexity of your CI/CD pipeline must be inversely proportional to the cost of a single transaction. If an error costs $100, manual deployment is acceptable. If an error costs the enterprise, your deployment must be automated and immutable. Audit your legacy code. Automate your state verification. Because if you don't engineer for resilience, the market will engineer your exit. I'm your host, and this has been the System Design Autopsy.